Good morning students. What was learned in the previous class ma? That is the working of potentiometer. What's the principle of potentiometer? How to compare the EMF of two cells by using the potentiometer, and then how to measure the internal resistance of a potentiometer. That all are learned in the previous class. In the today's session we easily learn about the meter bridge experiment. Meter bridge is in our practical is the first experiment, that is a meter bridge. Meter bridge, it will be used, this completely is based on the Wheatstone bridge. Simply tells this another form of meter bridge. Sorry, another form of Wheatstone bridge. Okay, so Wheatstone bridge is completely working on the basis of Kirchhoff rules. So without the Kirchhoff rule, it doesn't know about Wheatstone bridge and then meter bridge and then potentiometer. Okay, so in the meter bridge, it will be used to measure the specific resistance of one wire. ஒரு வயருடைய ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸை எப்படி வந்து நம்ம மெஷர் பண்ணலாம் அப்படின்னு பார்க்குறது தான் மீட்டர் பிரிட்ஜ். ஸோ மீட்டர் பிரிட்ஜ் இட் வில் பி யூஸ் டு மெஷர் த ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸ் ஆஃப் அ given wire. Okay, so we take the meter bridge board having only one string. That the string it will be having 1 meter length and it will be made up of manganese and constant metal, and then this is the copper strips, 1 strip and 2 strip and 3 strips. The wooden board, the strips will be fixed on the wooden board. The 3 strips will be individually connected, and then one metal plate will be connected to the one side and another one metal plate will be connected to the another one side. Okay, so then 2 strips will be connected to the 2 sides, and then 2 gap is there, first gap and second gap. First gap we fix one resistance box, that will be the unknown resistance. Inside of your book that circuit will be having this side is unknown resistance, but in our practical this side is the unknown resistance. Okay, clear that? So unknown resistance, what's the meaning that unknown resistance? That any one wire you have to fix in the gap that the thing does not know about the resistance. நீங்கள் இங்கே என்ன ஒயர் ஃபிக்ஸ் பண்ணுறீங்களோ அதோடைய ரெசிஸ்டன்ஸ் நமக்கு தெரியாது. ஓகே, ஸோ வி ஃபிக்ஸ் த அன்னோன் ரெசிஸ்டன்ஸ் இட் வில் பி இன் த 2 terminals, and then we fix the known resistance, it will be in the second gap. Okay, known resistance means we easily fix the resistance value. So we fix the resistance value, we easily find out the unknown resistance value. In this experiment 2 resistance will be fixed, one is known resistance, another one is unknown resistance. We find out the unknown resistance first, and then we will find out the specific resistance of a given wire. Okay, so that is the copper strips, 2 gap is there, that the gap first fix the unknown resistance, second gap it will be fixed the known resistance, and then this is the primary circuit, and then A terminal will be attached with one cell, that is called Lagrange cell or battery. So Lagrange cell will be connected to the one end of the board, and then negative terminal of the cell will be attached with the key, and the key it will be attached to the another one point B. Okay, then galvanometer, high resistance box will be attached with the middle point of the copper strip. Okay, so the middle point will be attached with the galvanometer it will be attached with the high resistance box, and a high resistance box will be attached with the jacky. The jacky it will be moving A to B. Okay, the jacky it will be mentioned the balancing length, it will be created by the cell. செல்லுனால எவ்வளோ பேலன்சிங்கில் வந்து கிரியேட் ஆகுது அப்படின்னு செக் பண்ணுறது தான் இந்த மீட்டர் பிரிட்ஜோடைய ஒர்க் ஃபர்ஸ்ட். ஓகே, ஸோ galvanometer it will be used to check the current flowing in the circuit or not, and then it will be shows the null deflection also. galvanometer ஒர்க் என்ன அப்படின்னா, ஜாக்கி நீங்கள் இங்கேருந்து இங்கே ரப் பண்ணும்போது galvanometer 0 டிஃப்ளெக்ஷன் காமிக்கும் போது தான் பேலன்சிங்லேருந்து நம்ம மெஷர் பண்ண முடியும். அதர் than that galvanometer will be used to measure the weak current also, and then galvanometer will be used to check the current flowing in the circuit also. Okay, so okay, then so again I tell that what are the components that will be used to make the meter bridge. First 3 copper strips is there and 2 gap is there. First gap it will be fixed the unknown resistance, and second gap it will be fixed the known resistance, and center point it will be fixed, it will be connected to galvanometer 1 terminal, and second terminal of the galvanometer will be attached to the high resistance box. High resistance box it will be attached to the jacky. Okay, then A point will be connected to the Lagrange cell, and the Lagrange cell will be connected to the key, and key it will be connected to the second terminal of the board. Okay, so first we fix the we on the Lagrange cell, we rub the jacky on the 1 meter long wire. One point the galvanometer shows the null deflection, That the point we have to note down. So that the point B by Q it will be equal to AJ by JP. What's the meaning that AJ by JP? AJ is L1, JP is L2. Okay, AJ by JP. This is the two balancing lengths. It will be balance the condition of Wheatstone bridge. Wheatstone bridge is P by Q is equal to R by S. Okay, P by Q is equal to R by S. So the two length, that is AJ and JP, it will be AJ and JP, it will be balance the Wheatstone bridge condition. Wheatstone bridge condition R by Q க்கு பதிலா இந்த balancing length தான் balance பண்ணுது. ஓகேவா? So AJ is L1 and JP is L2. It will be find out. Okay, so that the two values it will be mentioned in this experiment, and then B by Q is equal to J by JP is equal to L1 by L2. Then we want P is equal to, it will be ignore that P is equal to Q into L1 by L2. Okay, so this is the resistance of the wire, unknown resistance. நம்ம unknown resistance first find out பண்ணிட்டோம். ஓகேவா? Then again we mentioned that resistance is equal to specific resistance into L by A. Already you learned in the previous classes. Resistivity it will be equal to RA by L. So resistivity is the specific resistance. Resistivity and specific resistance. Rho is the specific resistance. Rho is the specific resistance. So rho is equal to RA by L. Okay, RA by L. So easily mentions rho it will be equal to P into A by L. Actually rho is equal to P into A by L. Okay, P into A by L. What's the meaning that P? That is the resistance, and R is A is equal to area of the wire. Area of the wire, you have to see the wire. This last part is one circle is there. Wire நீங்க பாத்தீங்கன்னா அதோட edgeல ஒரு circle இருக்கும். And the circle, so the area of the circle is pi r square. So P pi r square by L. That is called specific resistance. So specific resistance rho is equal to P into pi r square by L. This is the specific resistance formula. It will be used to find out the specific resistance of the cell by using the meter bridge. Okay, so this is the way you easily find out the specific resistance of the cell. Suppose you have to interchange the two resistance in the first cap and second cap. First cap la Q வையும் second cap la P நீங்க fix பண்ணீங்க அப்படினா you have to interchange the two two resistance. Again you have to find out the values, and then you have to fix the resistance for in the known resistance box. Known resistance box la resistance fix பண்ணி unknown resistance calculate பண்ணனும். ஓகேவா? L1 first unknown resistance ஐயும் known resistance இந்த பக்கம் போட்டு ரெண்டு resistance வேல்யூக்கு L1 L2 value we will find out, and then after interchanging of P and Q, again you have to fix the R value, and then you have to find out the L1 L2 value. So in our first practical we easily mention the first resistance value X is equal to X1 plus X2 by L. Okay, I will explain that with the components in the lab. Okay, so again I tell that what is the meter bridge experiment. Meter bridge board is having A and B point. A and B 3 copper strip is there and 2 gap is there. One gap it will be fixed as a one end resistance, that is P, that is the known resistance, unknown resistance, and second gap it will be fixed as the known resistance Q, and center point it will be connected with the galvanometer 1 point, and galvanometer will be attached to the high resistance box, and a high resistance it will be attached to the jacket. Okay, and then A to J is the balancing length of L1 and J to B is the balancing length of L2. The length wire is 1 meter, so 1 meter is 100 centimeter. 100 centimeter. Suppose A to J is 62 centimeter, L1 is 62 centimeter, so L2 is 100 minus L1, that is called 100 minus 62 is equal to 38, that is the L2 value, 38 centimeter. So how will you calculate? Continuously the one wire having 100 centimeter. The first is L1 வந்து 62 centimeter நீங்க எடுத்துக்கிட்டீங்கன்னா J ல B எவ்வளவு இருக்கும்? Total 100 ல 62 நீங்க எவ்வளவு சப்ட்ராக்ட் பண்ணீங்கன்னா என்ன வேல்யூ அதுதான் L2. So L1 it will be equal to one value, but L2 is 100 minus L1. We substitute the L1 value, easily find out the L2 value, that is AJ and JP. Okay, and then B by Q is equal to AJ by JP, it will be fixed, and L1 by L2 it will be easily find out, and P value it will be equal to Q into L1 by L2, and normally resistance R is equal to rho into L by A. We want rho, so rho is equal to resistance R A by L, that the resistance in our circuit, that is called P. So resistance P it will be mentioned as P, A is pi R square by L. Okay, so this is called as the specific resistance. Normally P it will be denoted as unknown resistance, rho it will be denoted as specific resistance. In this experiment it will be used to measure the specific resistance of a given wire. Then automatically end correction it will be produced in the two sides, so it will be taking the more and more value. You have to calculate the average value of the total values. Experiment nala enadhu, you be taking the more and more readings, we have to find out average value of the all the readings. Okay, so we calculate the average value of the all the readings. First find out the unknown resistance, next the unknown resistance we will substitute in the specific resistance formula, so easily find out the specific resistance value. Okay, this is the meter bridge experiment. I again explained in the lab with the components. Okay, next we will see some problems in our book. So first one example problem 2.25. In a meter bridge experiment with a standard resistance of 15 ohm in the right gap, the ratio of balancing length is 3:2. Find the value of the other resistance. In the meter bridge experiment, one resistance value is there. This is the known resistance value it will be given. So what is the given value ma? Known resistance Q value it will be given, that is 15 ohm. Okay. Then balancing length ratio. Balancing length ratio means L1 by L2 is equal to 3:2. That is 3 by 2. So 3 by 2. So easily find out L1 is 3 and L2 is 2. Okay. We want the resistance. What's the formula ma? P is equal to Q into L1 by L2. So substitute the Q value, substitute the L value, substitute the L2 value. So substitute the Q value, that is a 15 ohm. What is the L1? 3 and what is the L2? 2. So easily find out 15 into 3 by 2. So 15 into 3 by 2, we will calculate 1.5 multiply 15 into 1.5, 22.5. This is the resistance. So the unit is ohm. So in this problem, the given values are known resistance. Okay, it is a special resistance, that is called specific resistance. Specific resistance means known resistance. அதாவது இந்த ரெசிஸ்டன்ஸ் வேல்யூ நீங்கள் ஃபிக்ஸ் பண்ணியிருக்கீங்க. இப்போ பேலன்சிங்கில் இந்த L1 L2 உங்களுக்கு கிடச்சிருக்கு. அப்போ அதோடைய அன்னோன் ரெசிஸ்டன்ஸ் என்னன்னு உங்களுக்கு கொஸ்டின் கேட்காங்க. ஓகேவா? ஸோ ஃபர்ஸ்ட் we will consider Q it will be equal to 15 ohm and L1 by L2 is 3 by 2 centimeter. So L1 is equal to 3 centimeter and L2 is equal to 2 centimeter. Okay, so easily find out the unknown resistance P is equal to Q into L1 by L2. Substitute the Q value, substitute the L1 value, substitute the L2 value. So easily find out 22.5 ohm. This is the unknown resistance in this problem. Okay, and then second problem, in a meter bridge experiment, so in a meter bridge experiment, the value of the resistance in the resistance box connected in the right gap is 10 ohm. The balancing length is L1 is equal to 55 centimeter. Find the value of unknown resistance. How will you find out ma? L1 value is given and then resistance will be fixed in the right cap. Right cap is specific resistance. So we will find out the unknown resistance again. So what are the given values ma? So first specific resistance value is Q it will be equal to 10 ohm. Why you have to take the Q? So Q value it will be always fixed at the right cap. So right cap Q it will be equal to 10 ohm and then L1 value it will be equal to 55 centimeter. How will you find out the L2 value? How will you find out the L2 value ma? L2 is equal to 100 minus L1. Okay, so 100 minus 55, that will be 45 centimeter. Okay, so L2 value is 45 centimeter. Then so L2 value is 45 centimeter. We want P. So P is equal to Q into L1 by L2. Substitute the L1 value, substitute the Q value, substitute the L1, substitute the L2. So Q value is 10 and L1 is 55 and then L2 is 45. So we have to subtract, we have to divide all the things. How will you divide, ma? 2 5s are 10 and 9 5s are 45. Then 2 into 55 by 9, that the value is 12.12 ohm. Okay, you have to divide all the things, then you will easily find out 12.2 ohm. So in the previous problem L1 L2 value it will be given, but in this problem L1 value it will be only given, L2 we will find out. How will you find out? L2 is equal to 100 minus L1, so easily find out the L2 value. What's the formula? P is equal to Q into L1 by L2. So substitute the Q value, substitute the L1 value, substitute the L2 value. So Q value is 10, L1 value is 55 and L2 value is 45. You have to strike out the values and easily find out P is equal to 12.2 ohm. Okay, so 12.12 ohm is the final answer. So in this session, what's the basic principle of meter bridge and how the way measure the unknown resistance, specific resistance of a cell by using meter bridge. Meter bridge in the experiment it will be set and then easily find out the L1, L2 value and find out the first unknown resistance, and unknown resistance it will be substituted in the specific resistance formula. Specific resistance formula is rho is equal to unknown resistance into A by L. A is by R square. So P is equal to pi R square by L. What is L? What is R now? L is length of wire. So length of wire is 1 meter. Okay, that is 100 centimeter. Then what is R? How will you measure? Wire is very thin. That the wire having some radius. Radius already you learn in the 10th standard. The radius it will be measured by using screw gauge. The screw gauge it will be used to measure the thickness of one wire. So radius of one wire. So radius of the wire it will be nearly equal to 1.2 something, it will be anything. Okay, so radius it will be measured by using screw gauge. So radius it will be measured by screw gauge, that the value it will be taken, substitute the unknown resistance, substitute the pi value is 3.14 and substitute the radius of the wire and substitute the length of the wire. So easily find out the specific resistance of a cell by using the meter bridge. And then we solve the two problems, example problem 2.25 and example 2.26. Okay, so first problem Q value will be given, L1 value will be given, L2 value will be given. So easily find out, substitute the Q, L1, L2 value, easily find out the resistance. And second problem, L1 value only given and Q value will be given. So L2 we will find out and then substitute the L1, L2, Q value in this formula and then easily find out the specific resistance value 12.2 ohm. Okay, so and then I will explain that this experiment in the lab. Okay, then today's session homework, learn and write the meter bridge. Okay, learn and write the working of meter bridge. So home assignment for today's session. Learn and write the working of a meter bridge. Okay, learn and write the working of a meter bridge. Okay, thank you. Now I explain the meter bridge experiment. That the meter bridge experiment in our first practical, the circuit is there and then first we connect the electrical components in this experiment. First you should know about what is meter bridge board. That the meter bridge board having one string. That the board having 3 strips, copper strips, 1, 2, 3. Okay. Then 2 gap is there, first gap and second gap. First gap it will be attached with unknown resistance. Unknown resistance means meter bridge it will be used to measure the unknown resistance as well as the specific resistance of a given material. Okay, so we have to choose the unknown resistance. The wire will be rotating on the one wooden board. We want to measure the specific resistance of the given wire. In the wire specific resistance measure panna porom. Okay, so it will be connected to the second gap. Okay, inge rendu gap irukku, inge one. So the unknown resistance will be connected to the second gap of the meter bridge and then known resistance will be connected to the first gap of the meter bridge. Okay, node resistant means D-gate resistant box. Two terminal is there. Two terminal will be connected to the first gap of the meter bridge, and then so first gap is the known resistance is there, and second gap is the unknown resistance is there, and then A, this is the point A, this is the point B. Okay, A it will be attached with the cell it will be taken as Lagrange cell. So Lagrange cell positive terminal will be connected to the A terminal. Okay, and then B terminal it will be attached with the key. Okay, then key another one terminal it will be attached to the B. Okay, in the key or another terminal will be connected to the terminal B. Again I explained that two gap is there. Two gap, first gap I will fix the known resistance. Second gap I will fix the unknown resistance. Okay, second gap it will be fix the unknown resistance. Then you have to fix the resistance in the resistance box. We find out the resistance of the given wire. Okay, so first on the, and then this is the primary circuit, this is the secondary circuit. Secondary circuit will be connected with one cell and key. Okay, then center point of the meter bridge it will be connected to the galvanometer positive. Okay, this is the galvanometer. Galvanometer will be used to measure the lowest weak current, and then galvanometer also mention the current it will be falling or not. Okay, then the galvanometer will be connected to the middle terminal. Other term of the galvanometer will be connected to the high resistance box, and a high resistance box another terminal will be attached with one jacky. Okay, jacky it will be moving on the wire. The galvanometer produces a null deflection. Now also the galvanometer will be produced now null deflection, but I have to place on the one side of the string the galvanometer deflection is there, it will be producing galvanometer. ஒரு சைடில் நான் ஸ்ட்ரிங் மேலே நான் வச்சேன் அப்படின்னா galvanometer another side மூவ் ஆகும். அதே மாதிரி இங்கே வைக்கிறேன் பாருங்கள், இதோடைய லெஃப்ட் ஹேண்ட் சைடில் மூவ் ஆகும். ஸோ திஸ் இஸ் கனெக்ஷன் இஸ் கரெக்ட். ஓகே, இப்படி நீங்கள் so we had set the experiment. First you have to check your circuit is correct or not. First you have to fix the one side of the wire. The galvanometer shows the left side deflection. Okay, but you have to place your jacky at the another one side. The galvanometer deflected is the right side. So this is way only show the your experiment is well. So your connection is well. Okay, so so I have to place the jacky on the one side of the string. Then you have to I have to rub on the jacky on the string. The galvanometer it will be deflected, and then the galvanometer it will be the galvanometer needed it will be moving. Okay, then it will be goes on moving. I have to rub on the string. Then one point the galvanometer shows null deflection, isn't it? In the previous side it will be moving left side, in the other side it will be moving right side, but one point it will be gaining the galvanometer shows zero deflection. That the point we will measure. Okay, so we have to mention that is one side is 59 centimeter. So L1 is 59 centimeter. Okay ma, so L1 this is the balancing length. It will be created by it will be calculated by the meter bridge. மீட்டர் வச்சுன்னா ஒன்றும் இல்லை, நீங்கள் கேல்வாமீட்டரில் ஜீரோ டிஃப்ளெக்ஷன் வர்ற வரைக்கும் நீங்கள் அந்த நீடில் ரப் பண்ணிக்கிட்டே வரணும். ரப் பண்ணும்போது எந்த இடத்துல ஜீரோ டிஃப்ளெக்ஷன் கிடைக்குதோ அது வரைக்கும் உள்ள லென்த்தை மெஷர் பண்ணணும். லென்த் இட் வில் பி மெஷர்ட் ஃப்ரம் 0 to அந்த சைட்லேயும் ஸ்கேல் மெஷர்மெண்ட் இருக்கும், இந்த ஸ்கேல்லையும் ஸ்கேல் மெஷர்மெண்ட் இருக்கும். இங்கே ஜீரோலேருந்து எந்த வரைக்கும் இருக்கோ அந்த லென்த்தை நீங்கள் மென்ஷன் பண்ணணும். தென் அகெயின் யூ ஹேவ் டு சேஞ்ச் த ரெசிஸ்டன்ஸ், அண்ட் தென் யூ ஹேவ் டு அகெயின் யூ ஹேவ் டு ரப் ஆன் த jacky on the wire, and then you have to calculate the balancing length. Okay, the balancing length it will be increase before the better than the before reading. So first I read the reading is 59, now the reading is 74. Okay, again you have to change the resistance, and then you have to place the nearly 100. So you have to change the resistance, automatically the current value it will be get. So you have to always place the jacky on the string. You have to mention the balancing length, and then you have to tabulate it, and then you have to calculate the resistance of the wire, and then you have to put the resistance value on the formula. You easily find out the specific resistance of the wire. Okay, clear? Okay, thank you.